Okay, so welcome back. This is part 2 in our series where we're looking at this particular device here. And it's really a pretty amazing device. It's an Arduino Uno, and it costs at this point only $6 US plus a dollar something shipping. Pretty amazing. But not only is it an Arduino Uno, but it also has the additional capability to allow you to communicate with this device over Wi-Fi rather than just USB. And in part 1, we looked at some details about this device, and we even showed you how to upload a sketch that will allow this to scan all of the available Wi-Fi channels that sees all of the signals and print out information about the ID of the signal and what the signal strength is. So pretty impressive device. Now, in this video, we're going to take the next step and we're going to see how we can communicate with this device and actually access the GPIO pins, the analog and digital pins you see here, so that you can remotely control devices or gather data. So I encourage you to look at part 1 to see some of the basics about this. We also have a separate series talking about Wi-Fi communication with devices like the Arduino and the Raspberry Pi, and how to set those up and how to set up a simple application on your computer using C# or whatever software you want to use, and to allow it to communicate with those devices over Wi-Fi and show you how to use a client-server connection. And we showed you how to write a simple C# application and also a sketch on this Arduino to allow you to do simple communication with this device. In this video, we're going to look into a little bit more depth. We're going to show you how that C# application can talk over Wi-Fi and directly access the GPIO pins. And we're going to show you how to write some sketches for this to do that. And we're going to show you how to tweak the existing C# application we developed previously so that it can talk directly to the GPIO pin. So basically we're going to use sketches and C# applications we developed before with some minor tweaks to allow you to actually access these GPIO pins. And here you can see we've got our C# application running, and it is connecting over Wi-Fi to our Arduino Uno with Wi-Fi capabilities. And you can see it is sending a request to the client, which is the Arduino, and the result is 2.83 volts being read from one of the GPIO pins. And you can see up on the right, the output from the power supply that is being fed into the Arduino is the same thing, 2.83 or 2.84 volts. So again, there's no connection to the computer, only through Wi-Fi, and all we've got is a power connection to the Arduino, and then we're reading into the GPIO pins. So in this video, I'm going to show you how to get that all configured and get this application running. So here is a simple diagram of the Arduino Uno that we're using with the additional Wi-Fi capability. And it's important we understand this basic layout because it's going to help us understand how we can get this programmed and set up. So basically we've got, communications-wise, we've got a USB, micro USB port that you can use to connect to your computer. And that is going to this CH340 chip, which basically converts from USB protocol to serial, basically a 2-wire send-receive serial protocol. And from that, it goes to 2 main chips. Now, normally with a Arduino Uno, you've got this ATmega, which is kind of the CPU, central processing unit, but it does a whole lot of stuff. It does communications over USB. It accesses these analog and digital GPIO pins. It's an extremely capable chip that does most of the work of the Arduino. Now, with this device we have, this $6 device, it's also got a separate chip called an ESP8266. And that is a little bit like this ATmega 328. It's almost like having a separate CPU, which also has Wi-Fi capabilities. So the ESP8266 is very impressive chip because it's almost like a duplicate of an ATmega 328 with Wi-Fi. So this CH340 converts from USB to serial, and then you have these two devices connected via serial protocol. So the ESP8266 goes Wi-Fi, but it also has, surprisingly, some GPIO pins of its own. So again, you can see how it's kind of similar to this ATmega 328 with additional Wi-Fi. So on this board, we've got these ESP GPIO pins that you can address directly, but we're going to show you how to use the ESP8266 Wi-Fi to go over and connect to the analog and digital GPIO pins that you may be more familiar with the ATmega 328. So that's what we're going to do in this video. We're going to show you how to get that all set up. So here is the basic diagram. Now, in order to deal with these chips and to communicate with them, there's different modes you can enter in this device. And the different modes are going to allow you to communicate with either the ATmega 328 or the ESP8266 or between them, right? So it's important to keep in mind that you have to be in a certain mode in order to communicate with whatever chip you want to communicate with. The first mode is called Mode 1, and that is what you're normally used to with a Arduino Uno or Nano or whatever. And that's basically communicating over USB with your computer, and you convert to serial protocol and connect to the ATmega 328 where you have a sketch, and that allows you to access the GPIO pins. So this is the normal mode that you have on a regular Arduino Uno or a Nano. And you're basically ignoring this ESP8266. Now, you can enter this mode to either program the ATmega 328 like you normally do, uploading a sketch, or to operate with that sketch loaded, right? To refer to the GPIO pins. There's one mode that does both. One mode that you use for programming and the same mode you use for operations. And that's called Mode 1 on this particular device, where you connect from USB to the ATmega. And there is a set of switches we talked about before. There's 8 switches in this group here. And in order to get into that ATmega mode, you have to turn switch 3 and 4 on out of these 8 switches and leave all the rest off. So if you just want to operate like it's a regular ATmega 328 Arduino Uno, you put it with switch 3 and 4 on, and you've got that, and you're basically ignoring this. Now, if you want to deal with the ESP8266 and maybe access its pins or connect to Wi-Fi, you go into Mode 2. Now, with the ESP8266, there are 2 modes, one for programming the 8266 and one for operations. Now, you may be surprised to find out that you can actually upload a sketch to this 8266 just like you do with the ATmega 328. So you can write dual sketches, one for each chip, in order to operate the way you want. So Mode 2 is the programming mode from USB, where you upload a sketch to the ESP8266, and that is just for programming the ESP8266. Now there is a separate mode called Mode 3, where you actually you've already uploaded the sketch, and now you operate from USB to the ESP8266 and maybe connect to Wi-Fi or the ESP pins or whatever. So it's important to know with the ESP8266, there's programming mode, which is Mode 2. In that case, you have these switches 5, 6, and 7 are on. And then there's an operations mode with the ESP8266 where only 5 and 6 are on and 7 and the rest are off. So it's really important. If you want to deal with this ESP8266, you got to realize there are 2 modes. And that's called Mode 2 and Mode 3. But there's also a 4th mode. And this is what we're going to be focusing on in this video. And Mode 4 is when you basically forget about the USB connection, and what you're doing is you are communicating between the ESP8266 and the ATmega 328. And we're going to want to use that because that allows us to access the device over Wi-Fi, and we will talk to the ESP8266 and say, hey, ESP8266, can you please talk to the ATmega 328, which controls the GPIO pins, and could you tell it to grab some data from one of these, say, one of these analog pins, and send it back to me? So these two devices are going to talk to each other. Again, this is across what's called a serial connection, and you're going to be doing just like you do with a Arduino Uno, where you do a serial read and serial write. We're going to be doing the same thing where we're going to, the Wi-Fi from the computer is going to say, hey, ESP8266, talk to the ATmega. And this is going to be over the serial connection, which means there's going to be a serial write sending a command to the ATmega. And that command says, hey, ATmega, grab some data. It's going to go out, grab some data, and then it's going to do a serial write back to the ESP8266 with the right data. And then this guy is going to do a serial read to read that data. And once it's got that data, it can now send it over the Wi-Fi. So this is the mode we're going to focus on in this video, but we also have to keep in mind that we're going to have to program both of these devices. We're going to have to go into program mode, mode 3, to program this device, and we're going to have to go into mode 1 to program this device. And what those programs are going to do is, for the ATmega 328, it's going to be very simple. It just has to listen for, over the serial connection, it has to listen for a command from the ESP8266. It's going to wait for a command, and then when it gets that command, it's going to grab from whatever analog pin that we want, and then it's going to take that data and send it back to the ESP8266 using a serial.write. It's going to have a very simple sketch. Just wait for a command, grab data, and send the results. Now this one is going to be a little bit more complex, but we've already developed the sketch for this ESP8266. We've already uploaded it in the previous video. So I encourage you to look at those. All we're going to have to do with this is we're going to have to modify it a little bit to send a command to the ATmega and then receive the data. We've already got it so it can send that data back to the over Wi-Fi to the C# program. We're going to have to tweak that sketch to give it the interaction between itself and the ATmega. So again, this is going to be, the ATmega is going to be no different from doing a serial read and serial write as it does over the USB, but in this case it's going to be over the connection between itself and the ESP8266. So to get into that mode where they're talking between these two chips, we have switch 1 and 2 on and all the rest are off. So we're going to have a simple sketch for the ATmega. We're going to tweak the existing sketch for the ESP8266. And then for the C# application, there's really not going to be much change at all. So this should be fairly simple as long as we keep in mind these concepts. So here are the steps we're going to have to do. Again, we've done most of these before. We're going to have to prepare 2 sketches for the ATmega 328 and one for the ESP8266. Again, the ESP one is pretty much done. We're just going to have to tweak it. And then we're going to have to do a sketch for the ATmega. Then we're going to upload the sketch to the ATmega. And with the Arduino disconnected from power, set the switch positions 3 and 4 so that you can program the ATmega. Connect the Arduino to the USB port. Select the correct board. And this is very important. Since we're going to be talking to the ATmega, we need to select the correct board in the Arduino IDE. And it's going to be the Arduino Uno, not the ESP8266. So that's very important. We get that. Then we're going to do the compile and upload and then disconnect the USB. Then we're going to do the same thing for the ESP8266. With Arduino disconnected from power, set switch positions 5, 6, and 7 on. That gets us into programming mode for the ESP8266. Connect the Arduino to the USB port. And again, very important, select the correct board. Like we did last time, we were programming the ESP8266, not the Arduino Uno, not the ATmega 328. So we're going to have to select the ESP8266 board and compile and upload and then disconnect the USB. Then once those are both programmed, we go into the mode where we're talking between the ESP8266 and the ATmega, and that's switch 1 and 2 on, all others off. So those are the steps that we need to do to make sure we've got both modules programmed and then get into the mode where we can communicate. So now let's start with a very, very simple sketch we can use to program the ATmega 328. And again, all it's going to do is receive a command from the ESP8266 module over the serial connection between the two modules, then grab an analog value from an analog input, and then send that value to the ESP8266, again over the serial connection, so the ESP8266 can then send it to the C# application via Wi-Fi. So very, very simple sketch. We're going to define the analog pin as A0. You can define whatever you want. And then we're going to define a string called receive string, which is the string it's going to receive from the ESP8266 requesting data. And that's it for the parameters. Now the void setup is very simple. We got to set up a serial connection. Again, it's serial between the two devices. We're going to say serial.begin 115.200 baud. And then pin mode, analog pin input. In our case, we're going to read from analog A0. Pin mode, analog pin input. And that's it for the setup. We're all done. Now the loop, as we said, it's just going to wait for data to appear on the serial connection between it and the ESP8266. So if serial data is available, if it's got a request, it's going to define the receive string as serial.readString until new line character. So when we send a request from the ESP8266, it's going to end with a new line character. So this is going to say, okay, here's my complete string. And then if the receive string starts with L, now I use L character as a command to say, hey, log some data for me. You can use whatever you want, but in our case, if that string starts with L, then we're going to grab a sample and send it. And we're just going to use this method down here. And it's very, very simple. We're defining an unsigned integer of the log value, which is analog read. So read the value at that analog pin. And then again, it's a serial connection between the ATmega 328 and the ESP. So we do a serial.print line, which includes a carriage return line feed. If you don't know what that means, I did a video on carriage return and line feed. And then we take that log value and send it to the ESP8266. And that's it. It's a very simple sketch. Now it's important that we go here to the tools and select the correct board. So here we're going to board. Now it's set to the ESP8266, which is not correct. We need to set it to the Arduino Uno, which is Arduino AVR boards, and we go down to Arduino Uno. And now the setting is correct. Make sure we've got the right port and select the correct port based on what you need. And then we can do the upload, and we will have the ATmega 328 all programmed. Now we're going to do the same thing for the ESP8266, and a lot of this is already done. We already did this in previous videos on Wi-Fi and Arduino. So there's not going to be much change. We've got the ID, we've got the password, which I have asterisked out. We've got the IP address and the port of our server on the computer. And all we're going to do is, we've got everything set up, we're connected to the Wi-Fi, and here we're just looping through, waiting for a command from the server on the computer to come to this ESP8266. And we're connecting, and we are now reading from the Wi-Fi, client.read, to a character. And if the character is L, again, we're sending a L or log request from over Wi-Fi. If it's L, then we're going to send the L request from the 8266 to the ATmega. So this is going to be a little bit new than what we had last time. And we're going to use a serial.print line, which includes character return line feed, of an L. So that serial.print line is now going over the serial connection to the ATmega. And then we're going to wait and read string until, we're going to wait until we get a new line character, serial read string until, and that will be the response from the ATmega with the value. So receive string, and all we're going to do is take that string and do a client.print, which sends it over the Wi-Fi back to the C# application. So everything else is the same here that we had previously in our Wi-Fi series. All we're doing is we're tweaking this a little bit so that we now have to communicate with the ATmega, doing serial read and write, and then send that result. So that's about it for the ESP8266. Now to program it, again, we go up to Tools, Board. We don't want the Arduino Uno, we want the ESP8266, generic ESP8266 module, and then we have to select the right COM port, whatever your COM port is, and then we can upload this using the procedure I talked about, and we should be all set to go. The only thing we have to do now is make sure that everything is okay in our C# application, and we should be good to go. So here is our simple C# application we developed in the other series on Wi-Fi communication with the Arduino. And there's only some very minor tweaks we're going to do here. Basically, this uses first an event handler. We've got our two buttons here where you can start the communication, pause it, and exit. And the start button is going to basically run this listener method. And here is the listener method, and all it does, it's an asynchronous method, we talked about that is going to listen for connections where a client wants to connect, and all of that's going to remain the same. We're waiting for clients on whatever port we've identified. We define a client, and then once we're connected, we set up a network stream, and then once the client is connected, we're going to go through and wait for data to come. And then we're going to do a task.delay for 1 second and then do it again. So we're just going to loop through every second to see if there's data coming from the ESP8266. So here we're just setting up a write buffer, and we are going to send this L command. We're also keeping track of how long the round trip time is from when we send a command to when we get a result. And here we are basically writing over Wi-Fi the L command. We talked about this previously. We sent the L to the client, and here we're waiting for the result, and it's going to be a byte array called MSG, or message, and that's going to be the resulting value from the ESP8266, and it's going to be basically a number between 0 and 1023, which is reflecting the voltage value at the analog input. And we're doing an NS read, network stream read, and that will be our 0 to 1024 value. And then we are figuring out, once we got that value, we are ending the time span so we can figure out how long it took. And the only change we're going to make here is we are taking our message, our resulting message, which is a 0 to 1023 value, we are converting that to a string called val string, and we are now converting that string value of 0 to 1023 to an actual voltage value. And we have to use a reference voltage that the Arduino is using to compare against. And in our case, it's 4.88 volts. We did videos on that, how to do Arduino reference voltage. But it's not 5 volts. In our case, it's 4.88, so you got to be careful. And there's a simple equation to convert that 0 to 1023 value to 0 to 5 volts, and we do a convert to double this value string, whatever the result is, multiply it times the VREF over 1023, and that will give us a voltage value. And here we're just printing that out into our text box. So very simple. We convert the volts to string, and that's about it. So at this point, we should be set so that we can communicate over Wi-Fi with our Arduino and access the GPIO pins. So that's about it for this one. Again, I encourage you to look at the series on Wi-Fi communications. Very important you understand that. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.